Section 5.2, Finding Theoretical Probabilities. Okay, there are 4 probability rules that we're going to go through in this lesson. The first one is that probabilities are always numbers between and including 0 and 1, or as percentage form, we might call that 0% and 100%. You can give your answers back as fractions, decimals, or percents, so just pay attention to how MyLabs Plus asks for the answer back in order to get those correct. You can have a probability that an event never happens being 0, so it's kind of the low extreme. The lowest probability answer you can ever give back is 0 or 0%, and that's when something can never happen. So kind of a silly example to demonstrate that might be the probability that a person lives on the sun. That would definitely have a probability of 0. It is impossible. This could never happen. And then there's the other extreme. The probability that something would always happen would be 1. So something, I messed up my formatting there. It's P parentheses. The probability, think of something that is absolutely for sure going to happen. So my silly example is a human breathes air. That would have a probability of 1. And I'm sure you can come up with your own kind of fun cases for 0 and 1. Again, that's the same thing as 0% or 100%. And everything else should fall somewhere in between there. The next probability rule is that the probability that an event will not occur. So sometimes you want to switch the idea around and not say what's the probability it will happen, but maybe you're interested in the probability that it will not happen. You can calculate that by doing 1 minus the probability that it will occur. So kind of in notation, the probability that A does not occur is the same thing as 1 minus the probability that A does occur. So you can do that calculation if your question requires it. And then we have a definition that this leads us to. So something called complements. Complements are events whose probabilities add up to 1. The symbol A superscript C is used to represent the complement of A. And so with this notation, what I could say is that the probability of A complement is 1 minus the probability of A. So if they have to add up to 1, if I were to take 1 minus one of them, then what I should be left with is the probability of the other one. Okay, those are our first 2 rules. The third probability rule is just in general, if I'm looking at a question, how do I calculate up the probability of a certain event? So how you do that is you take the number of outcomes in A, and you divide that by the total number of outcomes. As long as your outcomes are equally likely, and in all of everything that we're studying, they will be. Okay, so let's just do kind of a fairly simple example to demonstrate that one. This says you're going to reach into a bowl without looking that has 5 red dice, 3 green, and 2 white. Find the following probabilities. So what this relies on is the idea that each die is equally likely to be chosen. None of them are bigger than or smaller than the others, or weighted differently so that it would make one more likely to be chosen than the other ones. So we can just use this number 3 rule here. A lot of times I like to start with the denominator, the total. So how many total die do we have to choose from here? We have 5, 3, and 2. So there are 10 total die. So that's going to be my denominator in all cases. And then I just need to put on top in the numerator the specific number of outcomes that fit this criteria. So if I ask for the probability of choosing a red die, well, there are 5 of them. So 5 out of the 10 would reduce to a half. So again, I could give my answer as a half if it asked for its fraction form. I could give it as 0.5 in decimal form, or I could give it as 50%. Any of these three are fine. Just look for how your question is, how it asks for it. So if we move to B for green, there are 3 greens. Now there is no reduced form for 3/10, so I could just give it as 3/10, or I could give it as 0.3, or I could give it as 30%, all the same. The probability of choosing a white die would be 2 out of 10, which reduces to 1/5. The decimal form of that is 0.2, or 20%. And then here's something that's very important. All of these probabilities, if we add them up, so the probability of red plus the probability of green plus the probability of white, those are all 3 options here, is 50% plus 30% plus 20% or 100%. So if you categorize every possible event that could happen, they should all add up